review part.
We could review it all that.
Not following. Okay, let's see here. So, looking at the study guide, the first part of the study guide says you should be able to explain some of the properties of water that can be attributed to its polar nature. The things we've talked about before. So, surface tension. Remember, the water molecules are attracted to each other because they have positive and negative ends. Low vapor pressure, meaning basically it's hard to get water into a gas because they don't want to leave each other because of those polar hydrogen bonds that form in between them. And then remember, water is weird because it actually forms a low-density solid compared to its liquid form, and that's because of the arrangement of the water molecules. They form those hexagons that have that empty space in between. Because the way they form those, they spread out from each other, which makes them less dense. So those are all things that we talked about when we talked about water's polar nature. Okay, number 2 says explain what a surfactant is and how it can help to wash dirt off of objects. So remember, a surfactant is something that disrupts the hydrogen bonding of the water molecules and allows them to be attracted to the dirt molecules. It's kind of a chain in between, because surfactants tend to have a polar side and a non-polar side. So one side that is polar and integrates with the water molecules really easy. They have another side that's non-polar and is attracted to the non-polar dirt molecules. Allows them to be dragged along with the water. Okay, we already talked about number 3, really. Ice has a lower density than liquid water because of the empty space in between the molecules when it forms those hexagons. Number 4, you should be able to define a solvent, a solute, dissociation, and dissolving. So remember, the solvent is the thing that's doing the dissolving, the solute is the thing that's being dissolved. You should definitely need to know the difference between dissociation and dissolving. Dissociation is where ionic molecules actually get taken apart into their ionic forms. So like sodium and chlorine, actually the molecules get pulled apart and surrounded by water molecules. It's not the same as dissolving. Dissolving, each molecule gets surrounded, but it doesn't get pulled apart.
What did you say about
Dissolving, you should. That's what I say. So, covalent molecules they can't get pulled apart. They just dissolve if they are able to mix into a solvent. Whereas ionic molecules will dissociate and their ions will get pulled apart. That explains why salt water will conduct electricity and sugar water will not. Because in salt water, the ions are actually separated, they're able to move to the opposite ends freely, whereas in sugar, there's no positive or negative charges. It's just dissolved electricity. There's no movement of charge, so the electricity can't be conducted. Okay, number 6, you should be able to explain what a hydrate is and be able to name and write a formula for a hydrate. So we can find a hydrate as just a molecule that has water molecules associated with it. Those water molecules aren't part of the formula, but they help form the crystalline structure. There will be some problems on the test where you are given a formula and you have to write the name with the hydrate part. So make sure you know your prefixes. And there will be some where you have to go the opposite direction.
And you only need to stop when you're actually writing out the formula, right?
Correct.
Many of them are stupid questions that I don't know how to do with the test.
Stupid questions that you don't know how to do. Well, on average, there's usually about 20%.
6, 7, and 8, 3, 5, 4.
Tells me nothing.
Okay, how would you make a 30 molar solution of sodium chloride if you have 5.05?
There might be one question like that on the test. It's a little bit harder. But you definitely have to do the simple type dilution calculations.
Okay.
So you have this many grams, this many milliliters, you should be able to figure out the concentration of the solution. You got to be able to do it for grams per mole, or sorry, grams per milliliter and molarity. So if I say you have this many moles of calcium hydroxide and you mix it into this many milliliters of water, what's the molarity? You should be able to calculate that too. So you got to remember the molarity is always in moles per liter. So you got to be able to convert between grams and moles. Okay, number 8 says explain the use of serial dilutions, be able to perform calculations for them. So remember, a serial dilution is where you take a little bit from one tube, mix it up, and you keep doing that. And the whole point of that is to get a low concentration of something without using a whole lot of solvent. It's an easy way of making up low concentration solutions. Okay, and in any of these dilution problems, remember the thing you want to be careful about is whether it's asking you to perform a calculation on something where you're diluting it to a certain amount or with a certain amount. So when you calculate the final concentration of the solution, remember you're always dividing by the total volume. That's easy if it says you're diluting it to something, because that tells you what the total volume is. But if you dilute it with something, you have to take into account how much you've taken out of the original solution and add that to the volume. We'll see both of those on the tests. So be careful about it. All right, number 9 says you should be able to describe the properties of suspensions and colloids.
Colloids are evenly mixed, just
Colloids don't settle.
Why?
settle.
They don't. Yeah, colloids don't settle.
Because the particles are big.
Right. The particles are bigger than in a solution.
And the suspension is like a colloid, but it just settles.
And
Our big particles.
they have even bigger particles. Okay, good. So you should know those. And then number 10 says you should be able to recognize the different types of colloids based on the phases of the medium and the dispersed particles. So if I had a question on the test that was something like, you have solid particles dispersed in a gas, what type of colloid would that be? The answer would be smoke. So those ones we talked about yesterday, smoke, gels,
Gels,
Foams.
solid and liquid, right?
salts. I would know all those. Fog would be an example of a. No.
Liquid in a gas.
Okay. Because there'll be a couple that I ask you based on the names what the phases are. There'll be a couple where I describe the phases. You have to name it. Make sure you study those. And that's pretty much all there is.